All right, in 5.2, we're going to introduce this thing called the unit circle and then a couple of functions, the sine function and the cosine function. The unit circle, I've started drawing it already. The point of this video is just to get you to understand the unit circle. So we've kind of alluded to this already. The unit circle is just a circle whose radius is 1 that is centered at the origin here. So it's this circle pictured in red. And this unit circle will end up being super important for us for the rest of the class. So really what we're going to do in 5.2 and to a lesser extent in 5.3 is we're going to learn a bunch of concepts that won't be that hard, but it'll be really important from kind of a foundational point of view for the stuff that we'll be doing later on in this chapter and in chapters 6, 7, and 8, which will be a little bit more challenging. So the idea with the unit circle are there are 16 points going around the outside of the unit circle that you want to have memorized. And when I say memorized, I mean you want to know the x and y coordinates of each of these 16 points, and you also want to know the angle measure in degrees between 0 and 360 degrees that would leave you at that point, that would terminate at that point. And you also need to know the angle measure between 0 and 2 pi that would terminate at that point. And you're like, wow, that's a lot. I need to know 4 things: x value, y value, angle in degrees, and angle in radians for each of these 16 points. You're really going to make me memorize 64 things? And I guess the short answer is yes, but the longer answer is it's not that bad. There's a lot of symmetry going on here, and I think you know a lot more about this already than maybe you think you know. For example, you already know that this point has an x coordinate of 1 and a y coordinate of 0, and this point up here would have an x coordinate of 0, y coordinate of 1, and similarly -1, 0, and 0, -1 are the x and y coordinates of these 2 points. And you're like, yeah, okay, that's not a whole lot. That's 4 of the 16 points. What about the rest of them? Well, I want to put the x and y coordinates on hold for a minute, and I want to first talk about the angle measure that would take you to each of these points. And since degrees are typically more familiar to students than radians at this point in the class, let's start with degrees. Often the symbol theta is used to indicate an angle. It's a Greek letter, and you'll see that a little bit throughout this class, but sometimes people get lazy and they're like, theta, that starts with a T, why don't we just use the letter T instead? And that's what I'm going to do for the purposes of this picture. If I want to talk about the angle between 0 and 360 degrees, and if I'm being really nitpicky, greater than or equal to 0, but strictly less than 360 degrees, that would leave me at each of these points. Well, for this first point is pretty straightforward. Since I measure from the positive x-axis, the angle that would leave me there would just be a 0-degree angle. In the interest of low-hanging fruit, maybe I can talk about the angle that would terminate up here. That would be a 90-degree angle. And then jump over here, that's a 180-degree angle. And then finally down here, I get a 270-degree angle. And it's worth pointing out there's lots of different angles that would terminate here. A negative 90-degree angle, for example, would also terminate here. But I'm looking for the angles that are in between 0 and 360. And you're like, why don't you throw 360 here also? I'm going to leave 360 off, although sometimes when you see these unit circles, they'll leave a 360 here. Because the way I'm going to define this is I'm looking for angles that are greater than or equal to 0, but again, less than 360 degrees. At any rate, that gives us these 4 points. The next 4 points I want to focus on are the 4 points that I haven't yet talked about that are labeled in blue. The defining characteristic of these new points is they're each halfway in between 2 points that we already have labeled. And we can exploit this fact to figure out the angle that would terminate there. If this is 0 degrees and this is 90 degrees, halfway in between the two would be 45 degrees. Similarly, halfway between 90 and 180 would be 135 degrees. And you can memorize that, or you can be like, well, it's 45 degrees more than this 90, and 90 plus 45 gets me this 135. Halfway in between 180 and 270 will end up being 225 degrees. And you can either memorize that, or you can find the average of 180 and 270. You'll find that that's 225. Or what I do is I remember that this is 180, and then I'm thinking, well, it's 45 degrees more to get down here, just like it was 45 degrees to get up here. Finally, this point down here, 45 degrees more than 270 would be 315 degrees. And we now have the degree measures for each of the angles in blue. Another way you could come up with these angles in blue is noticing that each time I take one step counterclockwise, I'm adding 45 degrees to the previous one. So 0 plus 45, another 45, another 45, another 45. That can fill out all the stuff in blue pretty quickly. But what about the stuff in green? Well, kind of like this point in blue is halfway in between 0 and 90, these points in green are 1/3 and 2/3 of the way in between 0 and 90. So 1/3 of the way from 0 to 90, 1/3 of 90 degrees is 30 degrees, and 2/3 of 90 degrees is 60 degrees. And once we know that these are 30 and 60 degrees more than this 0, we could figure out that these must be 30 and 60 degrees more than this 90. So 30 more than 90 is 120, and 60 more than 90 is 150. Similarly, 30 and 60 more than 180 would be 210 and 240 degrees respectively. And 30 and 60 more than 270 degrees would be 300 degrees and 330 degrees. And if that makes sense to you, great. It's worth pointing out that another way you can get all the points in green is kind of adding 30 each time. We got the stuff in blue by adding 45 each time. If you start down here at 0 and you add 30, you get to 30. Another 30 gets you to 60. Another 30 gets you to 90. Another 30 is 120, 150, 180, 210, 240, 270, 300, 330. In that sense, you could argue that 90, 180, 270, and 0 should be kind of blue and green. And I guess they should be. But I'm afraid that if I added that, it would kind of mess up my picture. What we now have are the degree measures that terminate at each of the 16 important points on our unit circle that you need to have memorized. So we've kind of checked off one of the tasks that we have for this video. The next task is we want to be able to refer to each of these 16 points in terms of their radian measure, not just their degree measure. And you're like, that's easy. In the last video, I learned how to convert degrees into radians. So I could just convert each of these different points into radians. And yeah, that's 100% true. You could, although I think that there's an easier way. So starting out at the easiest one, 0 degrees is also going to be equal to 0 radians. I won't even bother writing the unit radians. If you don't see a degree unit, you can always assume that we're talking about radians in this class. And then remember that it's 2 pi to go all the way around the circle. So halfway around the circle would be pi radians. Halfway to that pi radians would be pi over 2 radians. And 3/4 of the way around the circle would be 3 pi over 2 radians. But what about all the other points? Well, 45 degrees was halfway in between 0 degrees and 90 degrees. So similarly, this measure in radians should be halfway between 0 and pi over 2. Halfway between 0 and pi over 2 is pi over 4. And now we can just add pi over 4 to pi over 2 to go this much further than the angle that terminates up here, and that tells us that this angle measure must be equal to 3 pi over 4. Similarly, pi over 4 more than this pi would be 5 pi over 4, and pi over 4 more than this 3 pi over 2 would give us 7 pi over 4. If that addition logic makes sense to you, great. But if it doesn't make sense to you, we can do something similar to what we could have done with degrees, and just notice that these blue lines are all separated by pi over 4 from each other. So this is 1 pi over 4, this is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. And yeah, you don't write 6 pi over 4, for example, down here. You reduce that to 3 pi over 2. But you can get all of the radian measures pretty easily in their unreduced terms by just adding pi over 4 as you go around to all of the different blue points. And you can use a similar trick to get the measures that leave you at all the different green points in terms of radians. Remember, this point was supposed to be 1/3 of the way from here up to here. So 1/3 of the way to pi over 2 is going to end up being pi over 6. And now all you have to do when you're going around the circle to get from greens to greens or the x or y axis is add pi over 6. So this is going to be just 2 pi over 6. I'm not going to write 2 pi over 6. I'm going to reduce that and call it pi over 3. But you can think about this as 2 pi over 6. And similarly, you can think about this one as 3 pi over 6. No one writes 3 pi over 6. They write pi over 2, but 3 pi over 6 and pi over 2 are the same. Similarly, this 3 pi over 6 plus another pi over 6 will give us 4 pi over 6. But instead of writing 4 pi over 6, typically you write 2 pi over 3. This is 5 pi over 6. This is 6 pi over 6, but again, nobody writes that. 6/6 is just 1. This is 7 pi over 6. 8 pi over 6, which we write as 4 pi over 3. 9 pi over 6, which we write as 3 pi over 2. 10 pi over 6, which we write as 5 pi over 3. And finally, 11 pi over 6. What we now have are both degree and radian measures of each of these 16 points. That's a lot, and unfortunately we're not done yet, but we're getting pretty close. The only other thing that we need with our unit circle are the x and y coordinates of each of these different points. We already have the x and y coordinates for these 4 points because they just fall on the x and y axes. But what about the remaining 12 points in here? Well, again, let's start with the blue ones. Because the angle measure that gets us to this point is 45 degrees, and 45 degrees signifies a diagonal line, this point is on the line y equals x. And what that means is its x coordinate is going to be the exact same as its y coordinate. Oh, that makes sense. I have to go over to the right some amount and then up that same amount if I want to end up at this point. So what is that amount that I go both over and up? What is both the x and y coordinate of this point? Well, in the next video, I'm going to show you why, but it turns out that it's the square root of 2 divided by 2. And I'll give you some hints for memorizing this later on, but for now, maybe just trust me that this is the square root of 2 over 2. And you're like, ooh, these are already getting to be ugly numbers and there's 12 more I have to do? That's going to be miserable. And yeah, I'm not saying it's easy, but it won't be as bad as it seems because the circle has lots of nice symmetry. This point right here has the exact same y coordinate as this point, right? The height of these 2 points are the same. And their x coordinates are almost the same. As far as I need to travel to the right to get to this point is the same as far as I need to travel to the left to get to this point. What I'm saying are the x and y coordinates of this point are almost the same as the x and y coordinates over here. It's just now the x coordinate is negative. So based just on this point, I can kind of come up with this point. Similarly, this point down here in blue is pretty similar to the two of these guys. Its x coordinate, how far to the left it is the exact same as the x coordinate of this point that we just wrote. So we know it's going to be the negative of the square root of 2 over 2. And its y coordinate, how far below the x-axis this point is the exact same as how far above the x-axis this point is. So its y coordinate is just going to be the negative of the square root of 2 over 2. Finally, this point over here, same logic. Its x coordinate is the same as this guy, so it's positive root 2 over 2. And its y coordinate is the same as this guy, so it's the negative of the square root of 2 over 2. I still need to talk about why it's the square root of 2 over 2 to begin with, but if you believe me for that little fact for now, we can really fill out the x and y coordinates of all of these points, which is kind of nice. And you're like, yeah, but that's just the blue. What about all the green? Well, same thing. You're going to have to start out by trusting me on one fact, and I'm going to prove this fact to you in the next video. But I think if we could find the x and y coordinates of this point, we can fill in all of the green points. And you're just going to have to trust me for now until the next video that the x coordinate of this point is the square root of 3 over 2. Note, similar to this point, but not quite the same. Instead of a 2 underneath the radical, it's a 3 underneath the radical. What about its y coordinate? Well, again, you're going to have to trust me that it's positive 1/2. In the next video, I'll show you why. If you'll believe that this point really does have an x coordinate of root 3 over 2 and a y coordinate of 1/2, we can get all the rest of the points. How? Well, note that this point over here has the exact same y coordinate as this point over here, so its y coordinate must be equal to positive 1/2 also. What about its x coordinate? Well, the distance to the left that this point is the same as the distance to the right that this point is, so it's not quite root 3 over 2, it's the negative of root 3 over 2. Just like I can get this point in blue from this point in blue, I can get this point in green from this point in green. Similarly, I can get this point here and this point here. This guy has the same x coordinate of this as this guy, so negative root 3 over 2. And this guy's y coordinate is very similar to this guy's y coordinate, except it's negative, so it's negative 1/2. This guy has the same x coordinate as this guy, so it's root 3 over 2. And this guy has the same y coordinate as this guy over here, so it's negative 1/2. And you're like, yeah, but you forgot all of these ones. That's just half of the green ones. What about the other half? Well, now I can take advantage of some stuff I learned in inverse functions. This point up here is the reflection of this point over the line y equals x. The line y equals x is this diagonal line, and if we took this point and reflected it over that line, we'd land right here. Maybe you remember from inverse functions that when we reflect something over the line y equals x, we're really just switching its x and y coordinates. So because this point is reflected over the line y equals x from this point, it's got almost the same coordinates of this guy, we just have to change the x and the y. So this one's going to have an x coordinate of 1/2 and a y coordinate of the square root of 3 over 2. For what it's worth, a lot of students forget which one goes in which spot. A way you can remember it is if you just look at this point and kind of ballpark it, its x coordinate is right around here and its y coordinate is right around here. One of those things is about 1/2. Remember, this is 1 right here. This appears to be halfway in between the two of these guys. This is nowhere near halfway in between the two of these guys. So the x coordinate is the one that looks like it's 1/2, not the y coordinate. Similarly, this guy, its x coordinate is way down here, and its y coordinate is right here. It looks like its y coordinate is halfway in between here and here. Its x coordinate is not even close. So its y coordinate is the one that's 1/2. At any rate, once I have this point, I can do my same little trick that I've been doing. I can figure out the x and y coordinates here. The y coordinate, the height, is the same as the height here, so it's root 3 over 2. The x coordinate is similar, but the x coordinate is negative over here, so it's negative 1/2. Similarly, down here, this point has an x coordinate of negative 1/2 and a y coordinate of negative root 3 over 2. And this point has an x coordinate of positive 1/2 and a y coordinate of negative root 3 over 2. This is what's called your unit circle. It's something you will want to have memorized in this section, and it's something that we will use for the rest of this class. It's a lot, but there's lots of patterns in here, and you shouldn't think about it as there's 64 things I need to memorize: angle in degrees, angle in radians, x and y coordinates of each of these 16 points. Instead, kind of group them together and realize how you don't need to know that much stuff. Really, if you can just understand the first quadrant up here, the things in this little corner, you can get everything else from those. And the first quadrant isn't that bad. Most people can get the degrees and the radians pretty quickly. It's the x and y coordinates that give them trouble. But note that there's really only 3 choices for the x and y coordinates. It's 1/2, root 2 over 2, and root 3 over 2. I don't know if it helps any, but you can view this 1 right here as the square root of 4 over 2, and you can view this 0 as the square root of 0 over 2, right? Because the square root of 4 is just 2, and 2/2 is the same as 1. And the square root of 0 is 0, and 0 over 2 is just 0. And you're like, why would I ever write them that way? That's the stupidest thing in the world. Well, note that if you do that, and you think about this as the square root of 1 over 2, and you think about this as square root of 0 over 2, comma, square root of 4 over 2, then if you look at the y coordinates, it just goes root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. And if you look at the x coordinates, it just goes root 0 over 2, root 1 over 2, root 2, root 3, and root 4, all divided by 2. Nobody writes them that way. They simplify them, but that's one of the many patterns that you'll see going around here. And if you have a really hard time with stuff, that might help you remember them. And you're like, yeah, but how do I remember whether this starts with root 0 over 2 or root 4 over 2? Well, you know that this point has an x coordinate of 1 and a y coordinate of 0. So of course it starts at 1, which is equal to root 4 over 2. And you know that it has a y coordinate, a height of 0. So it's got to start at root 0 over 2. If that little trick helps you, that's fine. But don't leave your answers in red. Reduce them so that they look like the stuff in green and the stuff in blue. One more comment in the interest of memorization. Note that these points up in the first coordinate, they're always going to have positive x values and positive y values, whereas any point over here in the second quadrant is going to have a negative x value and a positive y value. So we figured these out one by one, and we talked about whether their x's should be negative or positive, but note that in each case, the x is negative and the y is positive. And similarly, down here in the third quadrant, our x coordinate is negative and our y coordinate is negative, which is why all of these coordinates are negative. Finally, our fourth quadrant over here, the x coordinate is positive and the y coordinate is negative. Hopefully that's enough information for you to memorize the unit circle. My advice to you is see if you can draw this all on your own. Like just grab a piece of paper and sit down and put on 16 points and see if you can figure out everything that goes all the way around. Maybe even think about it like if you were trying to teach it to somebody else, how would you have them remember this stuff and kind of pretend teach a class how to memorize the unit circle. Do that once, spend 15 minutes on it or so, and it'll be very worth the time going forward because we'll need this over and over again in this class.